Welcome back to Boiler Wild. My name is Eric Johnson. On this podcast, talk about boiler industry topics as well as personal development. You may be wondering, the name is a little weird, a little out there. I think it's a little amazing. I've had some other people tell me they like the name too, but the name of the podcast, Boiler Wild, Wild actually stands for work hard, invest yourself, lead others, and develop yourself into a person of excellence. Always strive to get better. And if you're listening to this podcast, I hope you want to get better in whatever area of your life. We got to have goals. We got to have dreams and aspirations. And just because you work around boilers, burners, steam, hydronics, and any of that doesn't mean you can't go out and achieve big things. So today I want to talk about what I call the point of no return. And this is a thing that is typically unique to boilers. So I will get into that more, but when you are working on like an air conditioner or even like just a residential furnace, if you do that kind of work, or, maybe a commercial air handler, you can easily shut down the air handler and fix it and then turn it back on, have an issue, shut it down, fix it, turn it back on. Same thing with air conditioners. Unless you are having to pull refrigerant out, then it's a little bit more work. But, you can still, if you make a mistake, re-pull the refrigerant out and all this stuff. With boilers, it's a little different. And I'm specifically talking about steam boilers, but a large hot water boiler, this would also apply, although it would be slightly easier to get past this point. And what I'm talking about, the point is no return, is when you have officially put heat back into the boiler. So when you are doing an annual maintenance, you shut down the boiler or this could be for any maintenance. It doesn't have to be annual, but at a minimum, typically a high pressure steam boiler is going to be shut down at least annually, and you need 24 to 48 hours to cool down the boiler. The boiler gets cool. You open up the fire side, you open up the water side, you're able to inspect everything. And this is the time that you need to make sure that you are dotting your I's and crossing your T's. Why? Because if you are going through your fireside inspection and you're doing a confined space inspection and you say, hey, I'm going to make this fix, and then you make the fix, but then you're not quite sure that you made the correct fix, or you re-roll some tubes and you do a hydro, it will seal up when the boiler gets hot. It's just a little weeping out of the tubes. It's good enough. Or on the water side, you have your pressure control tree, all your pressure controls, the operating control, if you have it, maybe a level transducer. You have a high limit control, anything that's going to measure pressure, anything that's going to be not have a valve on it. Those are critical. You need to check all that piping. You need to flush all that piping. You need to check all those pigtails. If there are pigtails, you need to check everything, because you need to have the mentality of, will this thing operate for another year? Because obviously nobody wants to shut down for maintenance that is unplanned. So we need to make sure that we are checking everything, that we are documenting everything, that we are inspecting everything. And if you don't flush your control lines, if you don't flush your pigtails, if you don't inspect that part of the boiler, and you may be thinking to yourself, well, I do that. Of course everybody does that. No, not everybody does that. I've seen it. Not everybody does it. That is not 100% normal to do, and a lot of companies will get quotes from different companies and there'll be different prices. Some companies, for an annual inspection, they will open up the boiler, the inspector will pass it, they'll close the boiler, they'll fire it and walk away. And then other ones do it correctly and actually check everything on the boiler and then do the combustion and everything. But the point of no return is, it is super easy to check all that stuff, but you close up the boiler, you fire it, you get a little bit of steam pressure in there, and then you wonder why your operating control isn't working. And then you find out that, oh, the pigtail under my operating control is plugged. Well, I have 100 psi of steam now on my boiler. Well, that 10-minute job to take off the pigtail, check it, clean it, or replace the pigtail now turned into a couple hours. And you can't just say, oh, we're just going to get to that later. No, the operating control doesn't work. You can't run the boiler now. So you either have to power cool the boiler, which means essentially you're going to somehow dump steam. You're going to turn on the fan and hopefully not thermal stress the boiler. And and this will take a couple hours to get the steam pressure off the boiler. And it also depends on how big the boiler is, whether it's a water tube and a fire tube as well. But whatever you're doing is probably not going to be great for the boiler. But in any case, that little operation that you missed can screw up your whole day. It can screw up the customer's day because they were expecting the boiler to be online by 5 p.m. and they have, production coming in ready to go for the second shift. And now it's not ready to go. And for whatever reason, the boiler's not ready to go because you didn't do all your checks. And I've seen this time and time again. One example I can think of when I was doing service back in the good old days is I had to go to a manufacturing facility, and this was after somebody else. And I was there really just to help and supervise, but I just asked, hey, did you do this? Did you do this? Yup. And turns out some stuff wasn't done. Got the boiler back on, and I am now there by myself. It is a little later in the day, after 4 o'clock, and turns out that the boiler doesn't shut down because the operating control is not sensing the steam pressure. And I look at the control tree, and this is a standard fire tube 200 horsepower boiler. And unfortunately, there's no load on this boiler, and I couldn't get a load due to the situation. But I'm looking at it, and I'm like, they said this, they said that. And why is this operating control not working? So spend a couple hours. The boiler had to be running that day. So I spend a couple hours bleeding steam and getting steam off the boiler to the point where I can start playing around with it. So I unwire the operating control, take it off, and I maybe only have a pound on the boiler at this point. And take off the operating control just to see if I can get steam flow out of the pigtail. Nope, zero steam flow. And it was at that point I was like, pigtail's plugged. So then I inspect the pigtail, and you can see the pigtail had just plugged solid. And typically what I've seen with steam boilers is everything will be working, and everything works because it is hot. It is moving the material around inside the boiler, the corrosion material, if that makes sense. Like when a pigtail plugs up, it may not plug up when the boiler is hot, when the boiler is online, but the second you cool the boiler and leave the boiler off for 24 to 48 hours, that pigtail and all the stuff in it can easily solidify in the center pinhole. I don't know if you've ever seen a pigtail that is plugged up. Typically, it just moves from the outside in. So on the inside diameter, it'll make buildup, and eventually it'll meet in the center, and there'll just be a tiny little pinhole that pressure can pass through, but then that pinhole will seal up, and now your pigtail is 100% plugged, and your pressure control won't work. So in this case, the pigtail was 100% plugged. I ended up replacing the pigtail and got it on, but that ended up costing me about four hours of extra work just because the pigtail was never checked, or it was checked very haphazardly, and now the pressure control didn't work. Same thing with internal inspection. If you do not properly repair refractory on the interior of a boiler, or inspect the tubes, or inspect on a water tube boiler, if you inspect the fire side properly and you heat up that boiler again, any amount of heat added to that boiler will make entering that boiler extremely difficult and or impossible again. So you have to make sure that you are doing everything possible that you need to, and you are dotting your I's, crossing your T's of, yes, this boiler is good to run. If not, taking pictures of questionable parts, questionable refractory, taking measurements, doing all this stuff, because once that boiler is fired and there's heat in the boiler, it is incredibly difficult and time consuming to undo that point. You can crawl in and out of a boiler, you can take stuff apart easily when there is no steam pressure on it. But once you put steam pressure on it, once you put heat in a boiler, the metal heats up, the water heats up. It now takes way, way longer to undo that, to typically do a little tiny job that you forgot about. So once again, I see this done with pressure controls. So you have to think of a mindset of, if I am going to do an annual maintenance on a steam boiler and it's typically only going to be shut down and opened, it may be shut down just periodically, but they're not opening it up for maintenance. So if we're shutting down the steam boiler once a year, I need to make sure that every single component is going to last a year. And you can't have the mentality of, oh, that looks good enough, or, oh, that has some blockage, but it's fine. No, you have to make sure that there's zero blockage and everything is essentially brand new in the way it looks. As far as piping, you may have some corrosion in the piping that needs to be written up. Hey, this piping is bad. It is corroded. It may leak soon, or we need to replace it now. Like, there's all this kind of stuff where some people I've seen where they will think, well, it looks fine for now. We'll see when, if it fails. Well, I don't agree with that mentality, because that's fine if you have a bunch of extra boilers, or you're, working at a small time facility and stuff. The costs typically of getting a new part and replacing it, and the little time extra spent of doing it correctly while the boiler is down, is way cheaper and way more efficient than shutting down the boiler again, getting another service call or more parts out there at a different time, and then replacing it, restarting the boiler, getting the steam back up to pressure and everything. Like, it just takes way longer, and you're doing over double amount of the work just for a tiny little job. And that's why with annual maintenance, you need to be making sure that everything is correct, everything is good, and with the mindset of, will this last for a whole nother year? Same thing with level controllers. So level controllers, differential pressure controls, they are typically found on DA tanks, feed water tanks, and you have a high leg and a low leg. They are also found on boilers. They require maintenance. If they get plugged up in the legs, they don't work, and then you'll have issues, and there's no valves to isolate them from the tanks, and you will have to shut down and pull the steam pressure off the tank. It's a little bit easier to clear out, however, still requires the ideal maintenance conditions of no pressure, and you got to make sure that the lines are clear. You'll have your reference leg. Obviously, you got to fill that up again I won't get too much into that, but essentially a differential transmitter does a math equation of one leg minus another leg, and it takes the difference of pressure between the two columns of water and determines the water level in your boiler or in your DA tank. And if one of those legs gets plugged up, that math equation changes and it'll tell you a water level that is not correct. And it'll either try to overfill or underfill your boiler. And I've seen companies that don't flush those lines, and it's typically just due to a person that doesn't understand what those lines are for or why they would be plugged and everything. You need to flush all the lines. If you have steam flow transmitters, you got to make sure that all those lines are flushed and not plugged, and inspect all those lines. Inspect any line that is going to be a measurement, because if those measurement lines get plugged, you are going to have issues. And once you have steam flowing again, it is infinitely harder to pull apart those lines. Another part of this is typically not on the boiler side, but on the steam side. But if you're doing a steam shutdown and if you have the proper isolation, make sure you are pulling apart your PRV and checking the orifices. So a typical mechanical actuated PRV that uses pressure, like the typical ones from Spence and Watson McDaniel. Hopefully y'all know what I'm talking about. They're typically seen in like a reducing station. You can also have back pressure valves on boilers, and it works the opposite of a pressure reducing station. It keeps the pressure in the boiler and will only open after the boiler reaches a certain steam pressure. Those have little sensing lines. Those have little orifices on the fittings, and if those orifice fittings get plugged up, the valves won't work, and you will either get steam trapped in the boiler, or if you have a PRV station, you will have steam not properly getting reduced and flowing to the other side of the PRV station. This is typically easier fixed because there should be isolation valves. But as we all know, isolation valves do not always hold. And when you have a 6-inch isolation valve and you're trying to pull apart a little PRV fitting, a tiny little steam leak can be a lot, and it can be hazardous, even though it's a tiny little leak through the valve. And that little leak makes it very, very difficult to pull the fittings apart, and you have to be very careful. I've done it before. It is not ideal. It is probably not safe, but you got to do what you got to do. However, it is way easier to do when there is no steam pressure, and it takes half the time to check everything, to flush everything, and it is just it should be the standard procedures of checking things as you go through the system when the steam pressure is off. But typically, if you are just shutting down a boiler, you're going to be isolated at the header and all the valves around the boiler, and you're not going to be looking at the steam system. If you're doing a full steam shutdown, you're going to want to look at your PRVs and other flow transmitters and everything to make sure that they are all working good. And if they're not working good, you need to make notes about them before that shutdown so that you don't forget anything. And that is very important. But with the boiler, the point of no return, you heat that boiler up, you're planning on at minimum 3 to 4 hours of having to cool that boiler down again. If you put steam pressure on that boiler, if you have to re-enter that boiler, if you have another tube leak that you didn't think you had. And while it will happen and you can get the job done and all this stuff, it is not ideal. You'll probably want to go home, or you just say, we'll have to come the next day. But then the customer, if they have a bunch of extra boilers, then they don't really care. But if they don't and they really needed that boiler that day, they're going to be inconvenienced. You're staying late. Of course, you're going to miss your kids for a soccer game and all this stuff. Like it's not ideal. And just taking the extra time and extra care to make sure that you are inspecting all the little things, taking off your pressure controls. And this is actually why I like pressure control tree or pressure control setup on a boiler without pigtails. I know some people just religiously put pigtails on it, but if you don't put pigtails on it and you make it like a drop header with a trap on it, and the entire header piping arrangement becomes the pigtail and becomes the water seal, you don't need pigtails, and now you can use tiny little 1/4 inch just straight pipe nipples on your pressure controls, or if the pressure controls are 1/2 inch, you can use 1/2 inch, but you can easily make it much easier to clean and much easier to inspect. And I've never seen a straight 1/4 inch pipe nipple get plugged up versus a pigtail, because the pigtails will always hold water in them, whether you drain the column or not, because of just how they are, unless you take the pigtail apart, and with that, then it gets debris in it and they'll plug up. But if you take just apart the piping of a drop header, that I like to call, or a water seal header, whatever you want to call it, where the header is piped so that it becomes the water seal instead of the pigtails, to keep direct steam, heat, and from reaching the pressure controls, you'll have, if you flush it out, you take the 2 plugs off the ends and you flush it out, you will have black water come out. You'll have some debris come out, but it'll clear up pretty quickly. And I typically like a 3/4 header on that at minimum. It makes it easier to see down it. It gives you more space. It is less likely to plug. I've seen some ones that are 1/2 inch. That is not ideal. My ideal setup would be 3/4 header, and you use 3/4 to 1/4 inch tees so that you are not having extra fittings. Some people will use 3/4 by 3/4 tees and then 3/4 to 1/4 bushings. You're adding more fittings to leak, more fittings to buy, but 3/4 to 1/4 inch tees are not standard buy and off the shelf, and that's why a lot of people don't use them. But anyways, that's another side project and side topic. But make sure you're inspecting those. Make sure you're repairing your refractory correctly. Make sure you're taking your pictures. Make sure you are sealing your handholds, especially your bottom handholds. It is very, very difficult to fill up a boiler, especially if you're filling the boiler from a DA that is already hot because it's feeding other boilers, and you're filling your boiler with 225-degree water, and your bottom handhole starts leaking when you have the boiler half full. Yes, you can dump the boiler, but now the boiler is hot, and dumping the boiler, you're wasting a lot of water, you're wasting a lot of chemical, and all because you didn't want to crawl along the floor and get a little wet and dirty to make sure that that handhole surface was clean. You didn't run your finger on the inside, maybe some sandcloth on the inside, making sure that there's no scale buildup on that surface, making sure that the handhole plate is proper and that the handhole plate is centered inside the handhole, and then you're properly tightening that and making sure the gasket is all aligned and proper. Overlooking proper handhole placement and manway placement with the gasket, that can easily screw you over, especially if you get some pressure on the boiler. I've had manways leak with 10 pounds of steam pressure on it, and there's not much you can do. Sometimes the manway is damaged and you don't notice, but a lot of times, and I don't want to just blame others with this. I take responsibility for not checking, but if you're working with somebody else and somebody else puts in the manway, and then you go on and then now the manway leaks and you look at it, you're like, oh, well, the gasket wasn't centered and, it's missing over on this side, or you put in the manway crooked and didn't tighten it like this. It doesn't really matter at that point, because the manway is leaking, and tightening it, no matter what, it won't seal up. And now you got to cool down the boiler enough in order to pull out the manway. I don't know if you ever tried to pull out a manway, even with just hot water in the boiler. The amount of residual water vapor that is coming out of that manway when it's on the top of the boiler, and I'm talking about a fire tube boiler in this case, the amount of just residual water vapor that is just rising out of that boiler. Makes it very, very difficult. You got to have some welding gloves on, a face shield, long sleeves, probably attach a wire to the handle. Like, it's super difficult to do, super unsafe to do safely. But sometimes you just got to do what you got to do. But if you just take the extra couple minutes to make sure your manway is properly centered and properly tightened, and that the surfaces are clean. I've seen people not clean the surfaces of a manway and leave old gasket on the surface, and that old gasket, they just think, oh, well, it'll be fine. The new gasket will just smash into the old gasket little bits and it'll seal up. No, it won't seal up, and now it's leaking. Also, I've seen this with McDonald low water cutoff controls, McDonald Miller controls, and you'll have like a 150 head. And if you know that will be a machined circular surface, and it'll have a cross hatch in it, but on ones that are pretty worn down, the cross hatching will have worn out, and you'll say, well, you should replace it. But not every customer has all the money in the world to just replace parts that aren't necessarily bad. And people will leave old gasket on those surfaces. And that surface is a very high tolerance surface where you have a gasket that is thinner or as thick as a 16th of an inch. I don't know how thick they are, but they are very, very thin. The little 8-hole gaskets. And then you have two surfaces coming together, and there's no play in those surfaces. I believe it's cast iron, some kind of cast iron. It's not going to bend or anything. So if you have extra material on those metal surfaces that is not planned, and you try to put a gasket on that, there's not a lot of extra squish on that gasket that is just going to take up all this extra space. And then I've seen people say, oh, well, you just need to put on some larger gasket, or they'll put on some, like, make a gasket. They'll use RTV and all this stuff. If you increase the measurement between those two bolting surfaces, you are now increasing the likelihood that you're going to have a leak due to the gasket blowing out. You're not going to have the proper clamping force. You're also changing the measurement of where that float is based on the water level. So I would not recommend that. If you cannot get those two surfaces to seal and you have cleaned the surfaces all the way, putting in a thicker gasket is not recommended. You need to replace the bowl or the head of the float, and or both. But I do understand, things aren't always perfect. However, taking that a little extra time to make sure that surface is clean and perfect is great, and it saves a lot of time. I remember another service call, and I don't even understand how I remember all this stuff, but I remember another service call. I got called out to a chemical facility, and walk in the room. They have, I think it's a 200 horsepower fire tube boiler, and the in-house maintenance person had put the boiler back together. And I'm not saying this is his fault. He probably shouldn't have put the boiler back together. He doesn't know, but he was just told by his boss to put it back together, to close it up. And he had not cleaned the surface of the McDonald Miller 157 bowl, I believe, or 150 head float. I don't know. McDonald Miller's sizing and stuff on their model numbers is super confusing, but the float, once again, the same surface that I was talking about, he had not cleaned the gasket surface properly and had tightened down the float side not evenly, and it was closer on one side versus the other due to the gasket surfaces, and he was just trying to tighten it more and more and more. But once you have a leak, no amount of tightening is going to fix that leak. That there should be no steam leak, even with a minor amount of bolting pressure between those two surfaces, since those two surfaces are machined and you have just a very, very thin gasket between it. So we had to power cool the boiler, get the steam pressure off of it, unbolt that. There was tons of extra gasket on that, and this guy thought that, I figured this extra gasket that I put on would be able to seal that up, and that I'd just be able to over tighten it. He was wrong. And, I took the time to educate him and say, hey, this is what it's supposed to be like. And this is how you do this. It was a service call for me, extra money for the company, but it was an extra expense for his company. Not that they really cared, but it's an extra couple hours that could have been avoided if he took an extra 10 minutes to clean off that gasket surface. And that's why cleaning gasket surfaces and making sure your handholds, manways, water side is all good to go before you fire the boiler, before you fill up that boiler. It makes the difference. I've been burned one too many times of putting in handholds by feel and not looking at them, not inspecting with a mirror, making sure that there isn't a little piece of scale that gets put under the gasket, and now you filled up the boiler and now it's leaking, and now you got to crawl under there and try to fix a handhole on the belly of a boiler that's leaking with 220-degree water. It is not ideal, very dangerous, and not recommended. And that's why you need to make sure that you are doing everything possible to do things correctly before the point of no return. And it'll make your life so much easier, because after you fire the boiler, you are increasing your statistical odds to have things go right and not have any pop-ups. But this is really why you have to have a little experience. And this is why, if you're an owner or somebody hiring out for your boiler maintenance, why this is the difference between a HVAC company that has guys that know how to turn some wrenches versus a boiler service company that actually knows what they need to do during a boiler annual inspection, or all the extra stuff that's not in the manufacturer's manual, or all the stuff that is special for your equipment, and to make sure that it is correct, it is cleaned correctly, it is maintained correctly, and that your boiler is put back together correctly so that you don't have issues with gaskets leaking and gaskets blowing out and all the similar stuff, either immediately or right after within the week. And I've seen so many issues with stuff like that, people not doing that. And I just want you to be educated and avoid those issues and be the person that does it right the first time and doesn't screw themselves over by having to wait a couple hours to cool down a boiler to do a 10-minute job that should have been done before the point of no return. So with that, I will leave you at that. Hopefully you learned something. If you're an experienced boiler person, you're probably chuckling to yourself and thinking about the one time that you screwed yourself over of this topic that I've talked about. If you have a time like that, please comment on the podcast app, or if you don't want a public comment, you can send me an email, eric.johnson@boilerin.com, or DM me on LinkedIn. If we're not connected on LinkedIn, look me up, connect with me. Happy to connect with you and hear your experience. If you've gotten this far, thank you. Please rate this podcast 5 stars on your podcast app. That helps me, and that helps other people find this podcast. I appreciate you all listening, and stay wild.